This video is going to pick up where we left off with our notes from the day. So this is day 1, chapter 9, day 1 notes. And this is right after the pineapple question. I'm going to start to talk about a p-value and what it means. So I told you guys that our goal of a hypothesis test is to reject the null hypothesis and rule in favor of the alternative hypothesis. Now, if we wanted to reject the null hypothesis and rule in favor of the alternative hypothesis, we have to have enough evidence to do so. And that evidence that I'm talking about is called the p-value. So the p-value is the evidence, the statistical evidence against HO and in favor of HA, which is the alternative hypothesis. So here is an example back from the one that we did whenever we did this, Friday. The player claimed that his long run proportion was 80%. So if you remember, he said, I'm an 80% free throw shooter, all right? Now we thought the opposite. We thought he was exaggerating and that his true proportion was actually less than 80%. He's exaggerating, okay? So let's say we want to prove that he is exaggerating. What we have to do is take a sample, a random sample of his free throws. So we take a simple random sample of 50 of his free throws, and that's called N, right? And we find out how many he made. And we see from that sample that he made 32. So we do p hat, which is going to be 32 divided by 50, and we get 64%. So right away you say, oh, look, that is indeed less than 80%. So is this enough evidence, because 64 is less than 80, is this enough evidence to prove that indeed he is exaggerating? So evidence is great, but is this statistically significant enough evidence? So basically we need to talk about the concept of a p-value. So how likely is it that if he was indeed telling the truth and he indeed was an 80% free throw shooter, that just by chance he made 64% or less of his free throws? Meaning, like this sample of 50 free throws, is this something that happened because indeed he's a worse free throw shooter than he says? Or was this just by chance that was like a bad day, but indeed he is an 80% free throw shooter? So we want to find the p-value, which is the probability, capital P, that the p hat, the sample proportion, is indeed less than or equal to 64%. Now, we actually have been doing this all in the last chapter. We found a sampling distribution of p hat. We found the mean of p hat, the standard deviation of p hat. We found the z-score for p hat, and we found the probability of something like this happening. Now, this is shown in the form of a simulation. So this simulation is showing a dot plot, and the dot plot is showing if we did this many, many, many times and did a sample of size 50, calculate how many he made, sample of size 50, calculate how many he made, and label all the p hats. Write down the p hat, write down the p hat, write down the p hat. So this is actually 400 repetitions of this, of samples of size 50. And these are all the p hats, all the values of the p hats of made free throws. How likely is it, what is the probability that his sample proportion is 64% just by chance, all right? So what you have to do is, in this setting with the dot plot, you would look at 64% on the x-axis, and you would calculate the p-value, which is the area at or below 64%. Now, you guys know if this were a bell curve question, we would have put the mean in the middle, mu sub p hat equals p. The p that he's claiming is 80%. And then to the left, we would put our p hat, 0.64. We would find the z-score for that, and then we would shade to the left. And this value would be the probability, which is the p-value of this value happening as extreme or more extreme than what just happened in his sample. And this dot plot, we just count. So if you count, you see there are 3 dots, 1, 2, 3 out of 400. So this is 3 out of 400 dots are less than or equal to the 0.64. So if you do the math, 3 divided by 400 is the probability of this happening, 0.0075. So the p-value of this happening is 0.0075. So this is similar to if I had actually done normal CDF or done a z-score and looked at table A, I would have found the area to the left, and I would have found this area to be 0.0075. So now, is this likely? Is it likely that this could have happened by chance? And the answer you should be telling yourself is no. This is very unlikely that this happened by chance. So, if it didn't happen by chance, why did it happen? Well, it didn't happen by chance. He did 50 free throws, and you know what he got? He only got 64% in. And it didn't happen by chance. It happened because he actually is not an 80% free throw shooter. He is less, okay? So remember, if your p-value is low, specifically lower than 0.05, which in this case it is, it's less than 0.05, less than 5%, it's unlikely that it happened by chance, which means it's rare that it happens by chance. So if it happened, it didn't happen by chance. It happened for a reason. And the reason it happened was because he's not an 80% free throw shooter. So this is the definition of a p-value. The p-value of a test is the probability or the likelihood of getting evidence for the alternative hypothesis, as strong or stronger than the observed evidence from the sample, if the null hypothesis is true. So what this is saying is, assuming the null hypothesis is true, assuming indeed he is a true 80% free throw shooter, and if so, we drew the mean to be centered at that 80% based on that assumption that it's true. How likely is it that he got this value by chance? And if it's not likely he got it by chance, that means that he got it for a reason, and the reason is because he was lying about his free throw percent. So if your p-value is low, how low? Less than 5%. You know what we're allowed to do? We are allowed to reject the null hypothesis. So we reject the null hypothesis, and we actually say, because my p-value of 0.0075 is less than alpha equals 0.05, which I'll talk about on the next page, less than 5%, I reject the null hypothesis. This is statistically significant evidence that I can conclude in favor of the alternative hypothesis, which says that indeed he is not an 80% free throw shooter. He is a less than 80% free throw shooter. Okay, so let's do one more example. Let's look at the next example. Calcium is important for bones. The National NIH recommends that the calcium intake is 1,300 milligrams per day for teens. So this is what is recommended. They're concerned that they are not getting enough calcium on average. Notice that word average means it's a mean question. Is this true or not? We are deciding to perform a significance test. Okay, so the null hypothesis is the statement of no change based on the past or based on the claim. So they're claiming that the true mean number of calcium should be 1,300, okay? So this would be in words that the average calcium intake for teens is at the recommended level. So it is where we want it to be. Now the alternative would be what they suspect. So they are concerned that they are not getting enough calcium, which would mean that it would be less than that amount. So you use the same symbol mu. Remember, the null is always the equal to sign, okay? The alternative is what you're trying to prove. So we want to prove that actually they're getting less than the 1,300. So you use the same symbol mu, the same number 1,300. You just change the sign now to be a less than sign. So this is called a one-sided alternative. So this means that the teens are getting less calcium than the recommended amount on average. Okay, on average, the teens are getting less calcium. So it's less than the 1300. So now we actually want to do some evidence here. We want to find some evidence. So we're going to do a sample, and the sample is going to be size 20. So that's N. And they record their calcium for the 1 day, and they compute the sample mean, X bar. So that's called a statistic because it comes from the sample, and the sample standard deviation, 411. Okay, so we have 2 statistics from the sample. And now we're going to perform a significance test, and we're going to get our p-value. Okay, so first thing I want to mention is we know the N, we know X bar, we know S. What we would have done is we would have drawn the bell curve. If it was approximately normal, but 20 is not large enough to use the central limit theorem. So we would have had to plot the data or look at the overall distribution to see if the parent population is normal. We would have centered it at the true value, which would have been the claim of 1300. And then we would have found the p-value, which would have been X bar 1198. So that's to the left, 1198, that's X bar. And we would have shaded to the left. And we would have wanted to know what is the probability, P, that the sample, X bar, is less than or equal to 1198 because it's less than that. And that value would have been that P value, the probability. So they said they did it and they got a P value of 0.1404. What does that mean if for the null hypothesis to be true? Okay. So if the null hypothesis were true, the true mean calcium intake for teens would be at the recommended amount of what it was, 1300, okay, milligrams. So that would mean that indeed the true mean was at that amount. Now, they are assuming that this is true, okay, that HO is true. They centered it at 1300 and they found the p-value to be 0.1404 or as a percent, 14.04%, okay? So if the null hypothesis were true, if HO were true, and this were true that the true mean intake of American teens was at the amount, the probability of getting a sample of 20 teens with a sample mean as extreme or more extreme. So in this case, it would be less than or equal to 1198 as extreme or more extreme than this sample amount is 14.04%. So 14.04% of the time, we're going to get a sample with this sample mean of 1198 or less in a sample of size 20 teens, American teens, okay? So is that rare or is it possible? The p-value of 0.1404 is not less than 0.05. So it is not statistically significant, which means that it is not enough evidence to reject the null hypothesis. Which means that we cannot rule in favor of the alternative hypothesis and conclude that indeed that the calcium level is less than the true amount. So basically this could have just happened by chance because 14%, it could have just happened by chance. So the sample size 20 could have just happened by chance that the sample mean was 1198, just by chance, because it could happen by chance. Remember, if it's unlikely that it happened by chance, it would be less than 5%. So if it didn't happen by chance, it happened for a reason, and the reason is because the alternative is true. This could have just happened by chance, so we can't conclude in favor of the alternative hypothesis. And thus, we don't have enough evidence to conclude that the teens are indeed getting less calcium than they should be.